hello and welcome to Math at a Go. Here we are in the fourth session of our day 3, the chapter called Polynomials. We will go through some final problems and the most important problems, thereby finishing this chapter to attempt the exam. Now the 11th one, divide 3x cube plus x square plus 2x plus 5 by x square plus 2x plus 1. Let us see. You have to divide 3x cube plus x square plus 2x plus 5 by x square. Now let us see how we do this division. Before doing the division, the most important thing we have to do is the terms must be arranged in the descending order of their powers. That means their powers must be slowly decreasing from highest to 0. So it is 3 here, next 2, next 1, next 0. It is happily arranged. For example, we are given something like this, x cube plus x minus 4. In that case, you have to write x cube first and search for x square. If it is there, write it. If it is not there, simply write it 0x square. Then term with power 1 is x to the power of 1. Next, the constant with power x to the power of 0. So, need not be written, and like this, you have to arrange it. So, you have to arrange the terms in the decreasing order of the powers of the variable. This one also you have to do the same. This is the primitive thing you have to do. Now let us begin the steps. How to do the division. It is same as the other division, but while taking the quotient, it's a little bit different. Let us see. Now how to decide the first term of the quotient. So to decide the first term of the quotient, you will take the first term of this one, the 3x cube, and divide it by first term of the divisor. Now what happens? So 3x cube means 3 into x into x into x divided by x square means x into x. 2x's go. So 3x remains. So this has to be taken as the coefficient, the first term of the coefficient. Now this and this have to be multiplied and the product must be written here. So multiply it, 3x into x square plus 2x plus 1. So 3x into x square is 3x cube plus 3x into 2x is 6x square plus 3x into 1 is 3x. So this is what we have to write here. So under this you write 3x cube plus 6x square plus 3x. Now you will have to subtract this from this one. You have to subtract this from this one. So what do you do for subtract? You will change the symbols of these. So you have to change all the symbols. If it is plus, you have to make it minus. If it is plus, you have to make it minus. If it is minus, you will take plus. But they are all plus here, you will take minus. Now, only this one is considered. The upper one is no more considered. Now, 3x cube minus 3x cube is 0. So instead of 0, you will simply cut it off, strike it off. Next, plus x square minus 6x square becomes minus 5x square. Next, plus 2x minus 3x becomes minus x. Next, plus 5. You have to take all the terms possible. Whatever are there, they have to be all copied. Not like other division where you take only one digit. Now, how to decide the second term of the quotient? For deciding the second term of the quotient, again you have to proceed the same way. The first term here has to be taken and it has to be divided by the first term of this one. So they will get cancelled. Now minus 5 remains. So this is the second term of the quotient. Now with this minus 5, you have to multiply the divisor. So x square plus 2x plus 1. So minus 5 into x square is minus 5x square. Minus 5 into plus 2x is minus 10x minus 5. This has to be taken here. So minus 5x square minus 10x minus 5. Now for subtracting, you have to change the symbols. Minus becomes plus, plus becomes minus. No. So minus 5x square plus 5x square get cancelled because of subtraction. Now this becomes 9x. Now this becomes plus 10. Now, should we continue? Of course we can continue, but because this is the division with polynomial and only you need polynomials, you should not continue the division. When should you decide this? So after subtracting, you have to decide, is the degree of this one less than this one or not? If its degree is less than this one, you have to stop there. So its degree is 1, its degree is 2. Then you have to stop it. Here its degree is 2 and its degree is 2. So at that time we continued. So when the degree of the so obtained after subtraction is equal or more, you will continue the division. If it is less than the divisor, you will stop it, and this will be considered as remainder. Now, is it right? Yes, we learnt in first chapter the division algorithm applies here also. Here, this into this plus this should give you this one. So let this be p of x, and this is divided by g of x. So let this be p of x, let this be g of x, and what the coefficient we get, let this be q of x, and the remainder be r of x. Then applying division algorithm, we can say p of x is equal to g of x into q of x plus r of x. Here r of x, its degree is less than this one. That means if its degree is 1, for example, its degree will be 0. That means it will be a constant. So when you divide any polynomial with first degree polynomial, the remainder will be a constant. Now you can substitute this and check it, and this will be valid. So it's asking us to verify. You can multiply it. For example, g of x is what? X square plus 2x plus 1 into q of x is 3x minus 5 plus r of x is 9x plus 10. So x square into 3x is 3x cube. X square into minus 5 is minus 5x square. 2x into 3x is plus 6x. 2x into minus 5 is minus 10x plus 3x minus 5 plus 9x plus 10. Now this makes one term. Now these two make one term. These two make one term along with this, and these two make one term. Now 3x cube. These two make it 1x square. These make minus 7x plus, so plus 2x plus 5. Is it equal to this one? So 3x cube, x square, 2x plus 5. So this is equal to p of x. Hence, division algorithm is verified. So using this, if only this and this and this are given, you can find this one, or any of them missing can be found out using this division algorithm. We have that kind of problems also. And now the final problem: obtain all the zeros of 3x to the power of 4, 6x cube minus 2x square minus 10x minus 5 if two of its zeros are given. So two of its zeros are given. So the two of the zeros are root of 5 by 3 minus root of 5 by 3. So these are already two zeros, and we need to find other zeros. He is asking us to find all other zeros. So how many zeros can it have? Because its degree is 4, it can have maximum of 4. 2 are already given, so probably we'll have 2 more. Then how to find that? Do you remember the divisibility rule for 6? If a number is divisible by 2 as well as by 3, that number is also divisible by 6. Why that rule is applied? When 2 and 3 are co-primes, this rule is applied for anything. So for example, if you have 5 and 6, if you have a number that is divisible by 5 as well as 6, that will be divisible by 5 into 6 is equal to 30. That will be divisible by 30 also. So if a number is divisible by 2 co-primes, that number is divisible by their product also. If these are zeros, then x minus root 5 by 3 and x plus root 5 by 3 are also divisors of this one. That means you will put the same with symbol changed and put x. You will put the same with symbol changed and put x. They will both divide this one, and they are both co-primes definitely. Every two different linear expressions, unless one divides the other, are considered co-primes. So these two are co-primes. Now their product must also divide this. So let us find their product. So what if you do their product and divide it? If you divide this, you will get one more small thing, and if you find out its factors, then that also becomes the factor of this one. So if you find the zeros of that one, they are also the zeros of this one. Let us see how. So multiplying both according to a minus b into a plus b, it becomes x square minus 5 by 3. Now you have to divide this by x square minus 5 by 3. So you divide it by x square minus 5 by 3. But as discussed, we must write the divisor and the dividend in the decreasing order of the powers of the variables. So it can be written as x square, but we don't have x, so let us put 0x, then minus 5 by 3. This will be making your job easy. Now let us make this x square plus or minus 0x minus 5 by 3. Now how to find the first term? As discussed, so 3x to the power of 4 by x square. So now x square means it becomes 2. So here 3x square is the first term of the quotient. Now multiplying this and this, x square into 3x square is 3x to the power of 4. 0x into this one is 0x cube. Minus 5 by 3 into 3x square. Minus 5 by 3 into 3x square. 3 get cancelled, so it becomes minus 5x square. Now for subtract, you will change the symbols. Now they both get cancelled. Now this happens to be 6x cube, and this is plus 3x square, and you will copy them all as discussed. Now to decide the second term of the quotient, you will take this one, the first term 6x cube, and divide it by x square. X square and this get cancelled, so 6x remains. So plus 6x remains. Now x square into 6x is 6x cube. 0x into this one is 0x square. Minus 5 by 3 into 6x is 3 ones are 3 twos are. So this becomes minus 10x. Minus 10x. So changing the symbols, they get cancelled. This becomes 3x square, and they get cancelled. This becomes minus 5. Now, is it considered as remainder or should we continue? Let us see. Its degree is 2. Its degree is also 2. So we can continue one more step. So to decide the third term of the quotient, you will divide this first term by this first term. So x square get cancelled. 3 remains. So it will be plus 3. Now 3 into x square is 3x square. 0 into x is 0 into 3 is 0. You need not write it. Minus 5 by 3 into 3. 3 get cancelled and becomes minus 5. So changing the symbols, they get cancelled, nothing remains. So 0 is the remainder. Therefore, when you divided this one, you got this as the. Now, when its factors are dividing this one, its factors also should divide this one. Yes or no? So let us factorize this one, then they will also divide this one. We know how to factor this one, let us see. So 3x square plus 6x plus 3. So let us find its zeros. Its zeros are nothing but the zeros of this one also. So how to factorize this one? We know we'll multiply both of these, the first term and the last term. 3 3s are 9x square. So we'll write it here in the rough. 9x square. How can you factorize it? 1 into 9, 3 into 3. Now this is plus into plus, so plus. So you have to add them to get the middle term. So where do you add? You will add these one. So this is the pair we want. So 3 and 3. To add them, they both should have the same symbol. What symbol should we take? The symbol for the middle term is plus here, so we will take plus for both. Next, x and x. So this must be split into 3x and 3x. So let us do that. 3x square plus 3x plus 3x plus 3 is equal to 0. So wonderful. It's all 3. So you take 3x common. It becomes x plus 1 here. And the same x1 if you take here, you get plus 3 here is equal to 0. So now this becomes x plus 1 to be taken common. This becomes 3x plus 3 is equal to 0. So from this we can write x plus 1 is equal to 0 or 3x plus 3 is equal to 0. This means x is equal to minus 1, or from this we get 3x is equal to minus 3. So from this x is equal to minus 3 by 3, that is equal to minus 1. So you got the same. Now minus 1, root 5 by 3, minus root 5 by 3. These 4 are the zeros of this one because its degree is 4. Now we have one more thing to say. When you factorize it like this to find the zero of a number, you got 2 zeros. You see, this is 1 0, this is 1 0. You are changing its symbol to add to the x. You see, minus 1 became plus 1, minus 3 became plus 2. And these two, when multiplied, you will get this. That means these two are the factors of this one. That is why we call this method as factorization method. So from this we can say whenever we have 3 and minus 5 as zeros to some polynomial, then change its symbol and make it minus 3 and add x. Change its symbol, make it plus 5 and add x. Now these two, if you multiply, you will get a polynomial which will have the zeros as 3 and minus 5. That means for that these two will be the factors. Like that, here the factors of this one divide this one, and from the factors you will get the zeros. If we take a quadratic equation and observe what happens as we go on factorizing and finding the zeros, you will find an interesting thing. Let us see. If this is the quadratic equation and we are finding its zeros using factorization. As usual, we multiply this and this, it happens to be 12x square. Now this can be factorized as 1 into 12, 2 into 6 and 3 into 4. Now this is plus into plus, therefore this happens to be plus, and as this is plus we have to add them to get the middle term. So 1 plus 12 is 13, not equal to 7, leave it. 2 plus 6 is 8, not equal to 7, leave it. 3 plus 4 is 7, therefore this is the much required pair. Now from this 3 and 4, what should the symbol be? Because this is addition, they both should have the same symbol. So what should be that symbol? The symbol of the middle term, the minus. So both of them should have minus symbol followed by x. Now this middle term has to be split into these two terms. So 1x square minus 3x minus 4x plus 12 is equal to 0, because we are finding the zeros. Now if you take x common, becomes x minus 3, and here the x minus 3 to be copied as it is. So here this goes away from the first term of this one, so minus 4 remains, so you take it as minus 4. Then taking x minus 3 common, you will get x minus 4 in this one, and from this we can understand that x minus 3 must be equal to 0 or x minus 4 must be equal to 0. This implies that x is equal to 3 or x is equal to 4. This is how we do it. Now let us take a reverse case and see what exactly happens. Let us think we are given the zeros, two zeros of a polynomial, and let them be 3 and 4. Now if the 0 is 3, we simply say x is equal to 3. So if x is equal to 3 and x is equal to 4, we can get this here. So this becomes x minus 3 is equal to 0. And if this is x minus 3 is equal to 0 and this is x minus 4 is equal to 0, if we multiply them both also, we will get 0. So this and this multiplied gets 0. If this and this multiplied, what you get? X into x minus 3 minus 4 into x minus 3. That is how we got it. And from this we get to this, and from this we get to this one. Finally, we have got a quadratic equation from the given zeros. That means when you have zeros, you can find the factors, and from them you can find the quadratic equation with the given zeros. So let us try it with alpha and beta. For example, if alpha and beta are two zeros, that means x is equal to alpha and x is equal to beta. In this case, if you get this here, x minus alpha becomes 0 or x minus beta becomes 0. If this is 0 or this is 0, if you multiply them also it will be 0. So x minus alpha into x minus beta will be 0. Then you can multiply it like this, x, you can multiply x minus beta minus alpha multiplied by x minus beta is equal to 0. So this gives you x square minus beta x minus alpha x minus into minus is plus alpha beta is equal to 0. So this gives us, this is the x square term, these two are x terms, the like terms which we call, and this is constant term. So this is x square and both have minus, so let me take minus common. So alpha plus beta, they can be added to get x, then alpha plus beta is equal to 0. So this is what we get the quadratic equation. That means when alpha and beta are zeros of any quadratic equation, the equation with them as zeros is this one. What is that? It is x square minus of alpha plus beta of x plus alpha beta is equal to 0. So alpha and beta are the zeros here. We can take it otherwise also. Here both of them are added and both of them are multiplied. So we can also write it as x square minus sum of zeros into x, sum of zeros into x plus product of zeros is equal to 0. This is also the formula you can understand. So you can find the quadratic equation when zeros are given, or even when the sum and the product of the zeros are given, you can find. You can directly substitute here and you will get the quadratic equation. And one more thing we can understand is, for example, this is x square minus 7x plus 12 is equal to 0. You multiply it by any number of your choice. Let us take it 5 here. So 5 multiplied by this. Let us see what we get. So 5 into x square is 5x square minus 5 into 7x is 35x plus 5 into 12 is 60, and this must be equal to 5 into 0, 0. Now if you factorize this and if you find zeros, what do we get? Let us see. Because you have multiplied it by 5, let us see what exactly happens. Do the zeros also get multiplied by 5 or what happens? Let us see. So you are multiplying the first term and last term. 65s are 300. So factorizing the 300 x square. Now this can be written as 1 into 300, 2 into 150, 3 into 100, 4 into 75, 5 into 60, 6 into 50, 10 into 30, 12 into 25, and 15 into 20 finally. Now it is plus and plus, so plus into plus is plus here. So we have to add the numbers of the pairs so that we get the middle term. So what should we get here? 35. So which numbers to add to get 35? Let us see. 113. This becomes 301, 152, 103, 79, 65, 56, 40, 37, 35. Yes, this is what we wanted. So 15 and 20 is the pair we wanted. 15 and 20. So this can be put with x and x. Now we have to add them, so we'll put the same symbol. What symbol? Decided by the middle term. The middle term has minus, so it's a minus for both. Now splitting this middle term into these. So 5x square minus 15x minus 20x plus 60 is equal to 0. So taking 5x common, we get x minus 3, and x minus 3 taking common here. So x goes away, so minus 20 remains, so minus 20 is equal to 0. From this x minus 3 taken common, we get 5x minus 20 is equal to 0. From this x minus 3 is equal to 0, or 5x minus 20 is equal to 0. From this x is equal to 3, or 5x is equal to 20, or x is equal to 4. So the zeros are x is equal to 0, either 3 or 4. So what did we get there earlier? It was the same 3 or 4, and here also it is 3 or 4. That means the quadratic equation, no matter by what number you multiply it with, always has the same zeros. For example, you multiplied by 5 here, you multiplied by 2020, the present year, you will get the same zeros, 3 and 4. That means this quadratic equation can be in this form or in some other form multiplied by any number, we will get the same zeros. So here, because we have taken this as a formula, so this can be the quadratic equation with alpha and beta as zeros, or multiplied by k also can be the quadratic equation with alpha and beta as zeros. What can be the value of k? It can be any real number. So this is the equation when you are given with alpha and beta, the zeros of a quadratic equation or quadratic polynomial. So this is the formula for getting a quadratic polynomial with given zeros alpha and beta, or when their sum and product are given. So what should be the value of k? It can be any number of your choice. It can be taken any way. But sometimes when you have some fractions here, you have to take the LCM of all, and the LCM must be taken as the k value, so that it becomes a proper quadratic equation without any fractions as its coefficients. Let us see the 10th problem now. Now the 10th problem says find a quadratic equation whose sum of zeros is 1 by 4 and product to be 1. So let alpha and beta be the two zeros. Then it says sum of zeros, in the sense alpha plus beta is equal to 1 by 4 and alpha beta is equal to 1. So it's asking us to find the quadratic equation. Is it possible to find? Yes, we have just learned it. The formula says k into x square minus of alpha plus beta into x plus alpha beta is equal to 0. This is the quadratic equation when alpha beta are given or their sum and product is given. Now it is sum and this is product. Writing like this is very important, because if you only remember this and this, you may get confused that they are equal to alpha and beta and not as given sum of and product of zeros. Please be careful. Now substituting the above values in the given formula, so k into x square minus of alpha plus beta is 1 by 4 of x plus 1 is equal to 0. Now k into this becomes x square minus x by 4 plus 1 is equal to 0. Now let us take LCM and apply this one to all. You can directly take k is equal to 4, but sometimes it may be trouble to you when this also happens to be a fraction. That is why I am telling you to take LCM. So what is the LCM? 1, 4, 1. So the LCM is nothing but 4. So let k be equal to 4. Then what happens? 4 into x square minus 1x by 4 plus 1 is equal to 0. Now 4 multiplied by this is 4x square. Now 4 multiplied this 4 gets cancelled and minus x plus 4 into 1 is 4 is equal to 0. So this is the quadratic equation with sum of the zeros as 1 by 4 and product of the zeros as 1. Even this is the answer, but we have a fraction as coefficient which a little bit appears like troubling us. Now we are comfortable here. So this is how we do it. And one final aspect which you though do not have in your syllabus, it is important to learn. So we have learned to find the zero of a first degree polynomial, the zeros of a quadratic polynomial, that is the second degree polynomial. And if someday we are given a higher degree polynomial like this cubic polynomial or fourth degree polynomial, do we have any method to find? Yes, there is a method. It's a trial and error method suggested by Horner, scientist called Horner. How do we do that? Let us see. This process is called Horner's synthesis. In this process, we arrange all the terms in the descending order of the powers of the variables first. If at all there is any power missing, we will put 0 and then proceed. So like that we arrange it like this: x to the power of 4, 5x cube, 5x square minus 5x minus 6. For example, if square is missing, we will simply write it as 0x square. This is how we write and then start the procedure. So what do we do here? We take only the coefficients. What is the coefficient here? It is 1. Always take it along with symbol. So it's plus 1. Then 5. Then 5. Then minus 5. Then minus 6. So all the coefficients taken in order. We will do it like this. Here this appears like LCM, but it's not so. So what should you do here? Take 1. It's a trial and error method. You may get or you may not get, just you keep on trying. So take 1. What is this one? Let me tell you. So take 0 every time here. Every time only 0. So 1, 0, 0. So 1 and 0, the algebraic simplification gives you 1. Now multiply this and this. and put what you get here. 1 into 1 is 1. Now this is plus 1 and this is plus 1. So this makes it 6. Now do it again. 1 into 6 is 6 here. So 5 and 6 make it 11. Now 1 into 11 is 11. Here it gives you plus 6. 11 minus 5 is 6. 1 into 6 is 6. Now minus 6 plus 6 go away. Finally this is the answer. Do you know what it is? Do you know what we have actually done? This is actually a division procedure. This is actually the polynomial wherein we have ignored the variables, but it is actually the polynomial which you divided by 1, in the sense x minus 1. That means this is a 0 and you will change its symbol and add it to x, whereby it becomes its factor. When can we call it a factor? Only when you get the last one as 0, because this is the remainder we get on dividing this polynomial by this polynomial, and this is the quotient. So that means now, because this is 4th degree polynomial, the next one what you obtained is the quotient is of 3rd degree. 1 degree reduces every time you do it, because it is divided by 1st degree polynomial. 1 degree goes down. So this is 4th degree polynomial. So this is 3rd degree polynomial. That means, for example, if you are dividing this polynomial by x minus 1, the quotient is 1, 6, 11, 6. How to write this? This is 4th degree polynomial. So we'll have a 3rd degree polynomial. So starting from x cube, x square and x. This is the result. If you want it, you can check it. So if you divide this one by x minus 1, you will get this as the quotient. In case you did not get this 0 as result, what would you do? Simply ignore this all and start from the beginning. So now this happened to me luckily. Every time you may not get the answer directly coming to 0. So you have to trial for numbers like 1, minus 1, minus 2, plus 2, minus 3, plus 3. Like that you have to go on checking. But before reaching the maximum of 4 or 5 values, you will get the answer. So now you divided this one by x minus 1 and the 0 is the remainder. Therefore, x minus 1 is a factor of this one, which means 1 is a 0 of this polynomial. That means this polynomial. So to this, 1 is a 0, which means x minus 1 is a factor. So let us check for the next one what happens. So do it with 1 again. 1 0, so you will get 0. So 1 and 1 1. 1 into 1 is 1, so it becomes 7. 1 into 7 is 7, so it's 18. 1 into 18 is 18. Here we have got 24. This is the remainder. So again, this won't be divided by x minus 1. So you will discard this off. This is discarded. You will start from the beginning again. You take this one, 1, 6, 11, 6 and divide it by minus 1 this time. Let us check it. Once you have done it with plus 1, so you will do it with minus 1, which means x plus 1 must be the factor. If this is a 0, you will change its symbol and put it to x now. So if this is a 0, this will be the factor. So let us see. You are dividing this one, the 3rd degree polynomial, by the linear polynomial x plus 1, and let us see whether we get 0 as remainder or not. Let us see. So 1 into 0, this one is 0. So 1 0 becomes 1. So minus 1 into 1 is minus 1. So this gives you 5. Minus 1 into 5 is minus 5. So this gives you 6. Minus 1 into 6 is minus 6. And this gives you 0 as result. So for this, minus 1 is a 0. That means x plus 1 is a factor. So if this is a 0 to this, this is a 0 to this also. Therefore, now we have found two zeros. That is plus 1 and minus 1. These two are the zeros for this polynomial. Now what is this we obtained? When it has 3 terms, it is a 2 degree polynomial. Or you can think it likewise. For example, on dividing the 4th degree polynomial, you got a 3rd degree polynomial. On dividing 3rd degree, you will get the 2nd degree polynomial. So this is 2nd degree polynomial, which means 1, 5, 6 can be written as 1x square, 5x plus 6. If you have any minus symbols, they will automatically come and sit here. So this is a quadratic equation. This could be solved by continuing also. But we have the method already learnt by factorizing, so through that you will go. So whenever you are given third or fourth degree polynomials, you have to go by this method in the rough and do it like this. If 1 is a 0, x minus 1 will be a factor. Next, in the next step, you will check for minus 1. If this minus 1 is a 0, then x plus 1 will be a factor. Now, you have got two factors, x minus 1 and x plus 1. So, you will multiply them, then you will get something like x square minus 1 because it is a minus b into a plus b. So, by this, if you divide this, you will get the same answer like where you got. So, you will do this one in the exam actually. Though this is for your idea only, you will do this one. So, you write it as this is a factor, this is a factor, therefore their product x square minus 1 is a factor of it. So let us divide this by this one, then we get this one. So on factorizing this, you will again get some more factors. Let us see what we get. So this can be written as x square plus 3x plus 2x plus 6. I think you understood how I am doing, because you must be perfect by this time. So x plus 3, now x plus 3 taken common, it becomes 2. So x plus 3 into x plus 2 is equal to 0. So x plus 3 is equal to 0 or x plus 2 is equal to 0. This means x is equal to minus 3 or x is equal to minus 2. So this is the method how we find the zeros of a fourth degree polynomial also. You see, because minus 3 is a 0, you change its symbol and add it to that. And multiplying both of them, you will get this one. From this, you will get a quadratic polynomial. So here, this is done in the rough part. So when you get zeros, you will keep it in mind and say, let us take p of 1. Then you will see that it becomes 0. Therefore, p of 1 is a 0 of the polynomial. If p of 1 is a 0, x minus 1 is a factor that you will write down. So like this, you will go on finding the polynomials until you get a second degree polynomial. And from the second degree polynomial onwards, you will follow the factorization method. Thank you. Good luck.